Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is word problems on the probability. In our previous video, we discussed the basics of probability. Now I am going to explain you how to deal with the word problems in the same topic. Finding the probability of an event in what follows, S is the sample space, the experiment in the question, and E is the event of the interest, that is N of S is the number of elements in the sample space, yes, and N of E is the number of elements in the event E. Here is the first word problem. Please read the question. A die is rolled. Find the probability that an even number is obtained. So let us first write the sample space yes of this experiment. So what would be the sample space? Sample space or nothing but the total number of possible outcomes. So there are 6 phases in a die. So what would be the outcome if you are rolling a die? So there are possibilities for any phase to come. So I can write it as, so this is the sample space. Let E be the event of an even number is obtained. So what are the even numbers? 2, 4, 6. Let us now use the formula of the classical probability. So what is the formula for a classical probability? Probability of an event is the number of event, the successful event, by total number of events in the sample space. So in the number of events, the successful event is even number. So 2, 4, 6, 3 outcomes are there, and total number of outcomes is 6. So 3 over 6, which is nothing but 1 over 2. That's it for this first example. This is the very basic example. Slowly I'm going to increase the difficulty level. Okay, now let us move on to the second example. Please read the given example. 2 coins are tossed. Find the probability that 2 heads are obtained. We know that each coin has 2 possible outcomes, either head or tail. Okay, as usual we are going to list out the sample spaces. The sample space yes is given by, so in a coin there are 2 sides. So if you are going to toss a coin, there are 4 outcomes, 4 possible outcomes. So let me list out all the possible outcomes as sample space here. So these are the possible outcomes. You may get head head or head tail or tail head and tail tail. This is nothing but in first toss you'll get head, and in second toss you may get tail. So same way here, in first toss you may get tail, and second toss you may get head. So these are the possible number of outcomes when you're tossing 2 coins. Okay, let us find what is E, probability of getting 2 heads. So how many outcomes? That shows only 2 heads. So this is the only one outcome among the 4. Am I right? So E be the event, 2 heads are obtained. After finding the sample space and event, we are going to use the formula of classical probability. Probability of E is equal to N of E over N of S. N here refers to the number, cardinal number. So how many event is there? Only 1 successful event, and total number of possible event is 4. So 1 out of 4. That's it for this problem. Hope you're clear with the steps. Okay, I'm going to give you one more example where you will learn the main important property of a probability. Please read the question carefully. Which of these numbers cannot be a probability? If you are saying that answer is not a probability, you should explain it. We have 6 options here. Let us start from 1. Okay, before starting with the answer, I'm going to give you one important fact. A probability is always greater than or equal to 0 and lesser than or equal to 1. So a probability should lie in between 0 and 1. Okay, please look at these answers. This number is less than 0, so this is rejected. This one lies in between 0 and 1, so this can be true. And what about this answer? 1.001. Even if it is a very small number greater than 1, you cannot consider this as a probability. So this is also a wrong answer. It does not lies between 0 and 1. Okay, option D. 0 is a number which lies in between the interval 0 and 1, and 1 is the last number in the interval. And what about 20%? 20% means 20 over 100, which is equal to 0.20. Am I right? And obviously it lies between 0 and 1. So these are the answers considered as probabilities. So only A and C cannot represent probabilities that lies in between 0 and 1, or lesser than 1 and greater than 1. These values are lesser than 1 and greater than 1. Hope you're clear with this concept now. Okay, let me take next example and explain you this concept. Here is the next example. 2 dice are rolled. Find the probability that the sum is equal to 1, equal to 4, less than 13. There are 3 cases. Okay, as usual, you're going to list out the sample spaces. So what is the sample space for this event? In case if you're tossing or rolling 1 die, you may get 6 event. In case if you're rolling 2 die, what will happen? 6 times 6. So 36 outcomes has to be listed out. Okay, the sample space, yes, of 2 dice is, I have listed all the possible outcomes. Okay, now let us consider part A. Part A is the sum is equal to 1. So this is the starting value, 1 plus 1, which is equal to 2. The minimum value of the outcome or the sum of the outcome is 2. So there is no event which gives the sum that is equal to 0. Am I right? So let E be the event sum equal to 1, and from the list of sample space we can say that there are no outcomes which correspond to the sum equal to 1. So probability of the event E is 0 out of 36. 0 out of any number, term or expression will be equal to 0 only. That's it for the part A. Hope you're clear with this part. Now let us move on to the second part. In second part, we should find the numbers that gives sum equal to 4. Okay, from the list, let us observe that 1, 3, 2, 2, 3, 4. Other than all these, the numbers are either less than 4 or greater than 4. So from the list, only these 3 answers will give you sum equal to 4. So E is 3. Now let's find the probability. Probability of the event that sum is equal to 4 is 3 out of 36. If I reduce the fraction, I'll get 1 over 12. That's it for this part. Now let's move on to the third part. You should get the sum less than 30. So from the list, you have to identify what are all the numbers less than 13. Okay. If you add this number, you'll get 2, 3, 3, 4, 4, 5, 5, 5, 6, 6, 6, 7, 7, 7, 8, 8, 9, 10, 11 and 12. And from the list of sample spaces, you can see that all the outcomes will give you a number less than 30, and no sum of the two outcome is equal to 13 or greater than 13. So you can say that all the possible outcomes, the number of event and number of sample spaces equal here, that gives a sum less than 13. So therefore, how would the probability can be found? Both the number of events and number of samples are 36. So the probability is n of E over n of S, which is nothing but 36 over 36. So that is just 1. Hope you are clear with this example now. So it is always advisable to list out the sample spaces until you get the practice. So after that, you may know what are all the sample spaces would be, because the experiments are always repeated. Rolling a die, tossing a coin. The same concept will be repeated again. And one more thing will be included is picking a card from a deck. So same thing. So you will know the sample spaces once you get a little practice. Okay, let me give you one more example. Here is the next example. A die is rolled and a coin is tossed. Find the probability that the die shows an odd number and the coin shows a head. So you have to find the probability where both these conditions are satisfied. Okay, as usual, we are going to list out the sample space. The sample space yes of the experiment described in this question is, so 1. So if you are rolling a die, you may get 1 to 6, and if you are tossing, it will be head, tail, head, tail. Okay, so the outcome would be, so this is the list of sample spaces. You will get 6 outcomes with head and 6 outcomes with tail. So let E be the event. The die shows an odd number and the coin shows an head. So odd number is 1, 3, 5. Head is this. So these are the outcomes that are odd and that shows head. Am I right? So n of the sample space is 12. Number of the events, possible successful event is 3. So the probability is n of E over n of S, which is nothing but 3 over 12, which is nothing but 1 over 4. Okay, so far we were discussing rolling a die, tossing a coin. I'd like to take one example from cards. Here is the example question. A card is drawn at random from a deck of cards. Find the probability of getting the 3 of diamond. So I'm going to list out the sample space. The sample space yes of the experiment in question 6 is, see, I have listed out the sample spaces of deck of cards. Okay, let E be the event getting the 3 of diamond. So examine the set of sample space shown on the board. There is only one 3 of the diamond. Am I right? So this is the only one outcome with diamond and number 3. So number of the successful event is 1 and number of the total possible event is 52. You can count. So I'm having 52 total outcomes. In that, the successful outcome is only 1. Therefore the probability would be 1 out of 52. So when you have a sample space, your probability steps would be easier for you. So always list out the sample space and find the probability. Find the number of possible outcomes and list out pick only the number of successful outcomes from the total sample space. So by dividing, you will get the answer. Please make sure that you give your answer in a simplified answer. Or you can just give your answer as a decimal or fraction or percentage. Okay, hope you're clear with this concept. In case if you have any query, please let me know. See you in the next video.